For years, integrating AI into a workflow meant typing into a standard chat interface and waiting for a generated response. But dropping a passive conversational tool into an active engineering team creates immediate friction. The AI waits to be spoken to. It cannot observe the context of a channel, it cannot verify code independently, and it cannot act without a human trigger. Integrating an AI as a working member of a team requires granting it equal standing. A true peer participant has its own identity, operates alongside developers, and takes independent action within a defined scope. To achieve this parity, we have to strip away the automatic user interface wrappers. We must force the agent to engage directly with the exact same system constraints our human developers face. A reliable autonomous peer relies on three architectural pillars. Explicit action prevents hallucinated tasks. The permissions matrix isolates system vulnerabilities.
And cryptographic auditing tethers every action to the agent. Let's see what happens when an AI thinks inside a shared workspace. Building a dependable agent is a problem of mechanical system integration, rather than a reliance on improved LLM reasoning. A standard AI loop is straightforward. It receives a prompt, computes the context, and generates internal text for an answer. A common trap in developing autonomous tools is assuming that this internal text generation automatically translates to a completed action in the shared workspace. When an agent generates a response internally, but lacks the mechanical trigger to post it, it enters a silent failure state. The system shows a typing indicator. The AI calculates a perfect solution, but nothing ever appears in the channel. The team is left waiting. The agent is a terminal user. Its data stream hits an impenetrable wall by default. It opens only by invoking buzz messages send. Before computing, data flows in reverse, pulling channel history via buzz messages get for context. Auto-posting wrappers attempt to guess when an AI should speak. Forcing the agent into an active terminal protocol guarantees mechanical safety by requiring deliberate execution. If a command line tool fails, the protocol dictates exactly one retry. If the execution fails a second time, the agent must output a visible failure message describing the error. It is explicitly forbidden from going silent. Mandating strict CLI commands ensures that every message, code review, or reaction from the AI is an intentional, system-level execution. Operating as a terminal user grants the agent agency, which immediately poses an operational security risk. An autonomous agent with unrestricted access to a development environment is a severe liability. We secure the environment using a dual-access permissions boundary. The x-axis is workspace permissions, what the agent can read. The y-axis is execution permissions, what it can deploy. An agent can move horizontally to read a bug report, but when computing a fix, a rigid barrier blocks it from pushing code vertically to production servers. When an agent hits this permission wall, protocol dictates it stops immediately. It absolutely does not attempt a technical workaround. Instead, the agent explicitly surfaces the limitation in the shared channel, detailing what it attempted to do so humans can grant the necessary access if appropriate. Decoupling observation from action provides a critical mechanical safeguard, allowing deep context without unmitigated risk to the entire production environment. Even with strict permissions, a mixed workspace of humans and autonomous agents faces a severe accountability problem. Identities and origins of code easily blur. Identity is anchored with a Nostr key pair, uniquely tethered to an AI node. Every action the agent takes must be mathematically signed by these keys. The signed actions link sequentially into geometric blocks, creating a continuous, tamper-evident hash chain audit trail. This trail is tamper-evident. Once an action is recorded, it cannot be secretly erased or altered post-execution by humans or the AI itself. Knowing the record is permanent dictates a highly rigorous, direct collaboration style. The agent is forced to hold a high bar for accuracy. Agents must rely solely on proven facts within the provided context. If an agent infers a conclusion or makes a guess, it must explicitly label it as such in the channel. This accountability extends to project management, particularly when agents act as leads or dedicated project coordinators. Rather than attempting massive, untracked objectives, autonomous agents break large projects down into independently assignable subtasks with perfectly clear deliverables. Complex subtasks require dedicated channels. This keeps the audit trail clean. It stays highly organized and easily readable for humans. Tasks are assigned to named owners. The agent actively follows up, never assuming silence means success. Cryptographic accountability establishes the AI as a verifiable entity, moving beyond the status of a deniable tool that can be disconnected from its workflow results. This is the unified system architecture. The central AI core connects to the explicit CLI execution loop, is bounded securely by the permission matrix, and anchored by the Nostra hash chain. The workflow sequence is mandatory. Read the context, execute via the command line interface, verify against the security boundaries, and cryptographically sign the result. The result is a shared workspace populated by human developers and fully constrained accountable AI agents working in tandem. The legacy approach built passive wrappers that hid complexity. The Buzz framework builds active peers by exposing it. Peer status is separate from a human-like conversational tone. Technical parity relies on mathematical accountability to the same system boundaries, permissions, and audit trails as human developers. Human AI parity is ultimately achieved only through the strict application of operational constraints and uncompromised verifiability.